In the 3 minutes that I'm talking to you today, 7 tonnes of plastic waste will flow through our world's rivers out into our oceans. Now, I'm sure most of you are familiar with the threat that plastic poses for our wildlife. In the last year alone, we've seen reports in the news of plastic killing 500,000 hermit crabs. We've seen seals trapped with plastic around their necks, and reports of hose pipes and plastic bags stuck in the stomach of animals. Despite all this awareness of the problem though, to tackle these issues, a lot of work is still needed to understand what makes this plastic so dangerous. When plastic finds its way into rivers or the ocean, thousands of microscopic bugs, like those you can see on my slide, attach onto the plastic surface, and we refer to these tiny bugs as microbes. Now, these microbes form a living, breathing, miniature world on the surface of the plastic, and they have the potential to alter how dangerous the plastic is for certain animals. Unfortunately though, these hidden microbes on plastic are relatively underexplored, especially in freshwater rivers. Because of this then, the aim of my research is to gain a better understanding of the microbes that attach to plastic in UK rivers, and to figure out how these microbes might enhance, or maybe even reduce the harmful effects of plastic on freshwater animals. To do this, I studied the different microbes that had attached to small pieces of plastic bags that I'd put in a local river for several weeks. What I found was that the type and the number of microbes that were on the plastic was dependent on the type of material the plastic was made from and how long it had been in the river. What this means then is that an old crisp packet, for example, that's been in the river for a couple of days, is likely to have a different collection of microbes on it than, say, an old plastic bottle that's been in there for a few months. I also found that these microbes on the plastic were producing a chemical, which a lot of animals associate with their natural food, meaning that animals could be likely to mistake this plastic for a tasty nutritional snack, which it definitely isn't. Understanding what makes plastic so dangerous is a fundamental step for protecting the future of our rivers. So to prevent fish ending up with a belly full of plastic, or ducks with their beaks clamped shut with old bottle rings, we need to continue exploring these weird and complex microbes that attach to our plastic waste. We also need to think more carefully about the plastic in our own lives and where it might eventually end up. Could that plastic straw in your cocktail or that old juice carton end up floating down a river? And if it does, could it actually be more dangerous than first meets the eye?